The 24-hour day feels permanent, fixed, like gravity or the speed of light. Something the universe simply decided, long before you arrived. It wasn't decided, it was earned. 4.5 billion years ago, a full day lasted 6 hours. The world spun so fast, the equator moved at 10,000 kilometers per hour. There was no civilization, no ocean as we know it, no air we could breathe. But there was time, and it was already running out. It began with a collision. A planet the size of Mars, scientists call it Theia, struck the young Earth at a glancing angle, at nearly 10 kilometers per second. The impact was catastrophic. Rock vaporized. Oceans of magma splashed into space. The debris that escaped coalesced, within decades, into the moon. But the collision left something else behind. Spin. The post-impact Earth emerged as a furious, molten spheroid, rotating every 4 to 5 hours. And the moon, still forming from that same expelled rock, hung just 15,000 miles away, 16 times closer than it is now. A vast body that seemed to fill a third of the sky. The gravitational bond between them was absolute, and the clock began. The moon did not slow the Earth by force. It did it with patience. Its gravity reached into Earth's oceans and mantle, raising 2 great tidal bulges, one facing the moon, one on the opposite side. But Earth spun faster than the moon orbited. The planet dragged those bulges forward, always out of alignment. And the moon, always pulling back, acted as a constant planetary brake. The energy lost by Earth's rotation was transferred outward. The moon absorbed it and drifted away. Today, it retreats 3.8 centimeters every year. In the early Hadean, when the moon was close and tidal forces thousands of times stronger, the day lengthened rapidly. 6 hours became 12. 12 became 18. The world was winding down. Stand on the early Earth. The sky cycles every 3 hours. Sunrise, noon, sunset, darkness. The Coriolis forces, driven by that violent spin, are 4 times more powerful than today. Storms don't form as we know them. They shatter into dozens of ferocious latitudinal bands, each one dwarfing any modern Category 5 hurricane. And the tides. With the moon so close, the oceans didn't rise by feet. They rose by kilometers. Researchers estimate tidal waves reaching 3 to 7 kilometers in height. Mountains of water surging hundreds of miles inland every few hours, scraping the primordial crust, dissolving minerals, dragging organic compounds into the sea. Those tides may have seeded the chemistry of life itself. Then, for 1 billion years, the clock seemed to stop. Between 2 billion and 600 million years ago, the day stalled at approximately 19 hours. The moon was still pulling, but the sun was pushing back. Solar heat created pressure waves in the atmosphere, and at this precise day length, those waves synchronized with Earth's rotation. The solar push exactly matched the lunar drag. A standoff, lasting 1 billion years. And in that standoff, life was waiting. Cyanobacteria, organisms capable of photosynthesis, had existed for over 1 billion years. But they couldn't oxygenate the atmosphere. The days were simply too short. It took hours just to ramp up oxygen production, and night kept arriving too soon. When the moon finally drifted far enough to break the stalemate, and days crossed 21 hours, the cyanobacteria exhaled. Oxygen flooded the oceans, then the sky. Every breath you take began with the moon moving away. One face turned permanently toward the moon, the other facing away, scorching heat on one side, permanent darkness on the other. But the sun won't wait. In roughly 7.6 billion years, it will expand into a red giant, boiling away the oceans that make tidal friction possible. The story of the slowing Earth ends not with stillness, it ends with fire. Every second of this day is the product of 4.5 billion years of physics.